afternoon. My talk is not going to be as slick as Reese. That was a very good show, Reese. If you look at the last word, it says intentions. Okay, so none of the stuff which I'm going to show you has been done yet, but I have the intention of doing it, and I want to just say that when I started working at the Geological Survey as a young guy, I had to share my office with a senior technician, and he had three trays. He had in tray, good intentions, and out tray. And the good intentions one was stacked up like this, whatever, and in and out. They were almost empty. So I didn't call it good intentions. I just call it intentions. Tailings facilities. The failures, they are often in the news. This morning, somebody else has already mentioned the Brumadinho dam disaster in Brazil, and there was another one, Germano iron mine, that was in 2015. Not for us to be outdone, whatever. We also have our spectacular ones. Those of you who are as old as me, you might remember the 1994 the Mary Spruit, and then in 2019 there was Jagersfontein. These failures are so important that there is a website. Somebody else also mentioned that already, so I will not dwell on that. You can, in fact, go on these keys and just click on them, and then they will open up in more dots and so on, whatever, and they will give you the health of each of these TSFs, as we call it. Okay. So I want to make a proposal. Okay, this has been when the West asked me to give a talk here. I was racking my brains, and I bought myself a large glass of red wine, and so I came up with this. Why can we not use infrared sensors that looked inside into a TSF facility? The reason I'm thinking that is that about 25 years ago, I helped a homeopath. He was trying to diagnose cancer, and that was the first time that we bought a little infrared sensor, and you had to stand on a pedestal that was circling around in a sort of a room, and in the sensor that went up and down, and I had to help him to write the software to do some finite element analysis that you look inside of the body. Now, today, it is much more advanced. You can buy these things off the shelf, whatever. And so we had a good idea then, whatever, but we didn't follow through. I could have been a rich man today. So I want to try this on TSFs. And there is the proviso, whatever, that it will not work on this type here. Okay, this type is surrounded by the mountains, but you want to do a type of tomography. So it means that you must be able to look at your TSF at least from the top and from the side walls. Okay, so these types here, they will be probably possible, I think, whatever. I don't know yet. This is my favorite one, and I will use this further. So how do I propose that to do that? Oh, okay. Of course, I'm going to do it. The drone surveying. We've got a capability there of handling difficult terrain. You can see there the megatometer tanks below the drone, and that's on top of Gamsberg, the mountain. So how would we do that? I just have to go a little bit back to the mathematics. You probably during your studies you will experience this at the start of finite element the modeling, and they have a brass plate, and it is kept at a temperature on one edge. See if I can move this thing there. So you're heating it up here, and you're measuring your temperatures there, whatever, and then you want to reconstruct what's happening on the inside, and you want to calculate the diffusion of the heat through these two boundaries. And this is a very simple example. In nature, of course, this example does not consider different materials and different heat propagation properties. But we have to start somewhere. Okay, so I'm thinking if I have a infrared sensor, and there are many of them. If you go onto the internet, there are hundreds of them, whatever, and all for a specific aim. But I will go for one. This example, for instance, Hamamatsu, that records both shortwave and longwave radiated energy, and you fly these things by drone, and you have different flight lines, whatever. That is just one flight line. Okay, that plane there, and you treat that plane in the beginning at this sort of problem. Okay, so you can hopefully, I hope, get some idea of what's happening on the inside, whatever. Of course, your lower interface, you would have to keep it at a constant temperature, so that is normally the average of the Earth, I think, is 15 or 16 degrees Celsius, and then you would set up a finite element analysis procedure, and again there are hundreds of them. I'm not going to delve into that, and if you're lucky, you are not going to get like this, because this is much too much detail. I'm expecting much less detail. This is an experiment which somebody has done on El Capitan in the Yosemite National Park, whatever. If you follow the doings of a rock climber, Alex Honnold, then you will come to this paper also, whatever. Okay, so I just clipped that up because I couldn't find anything somebody has done before on this subject. Okay, type of modeling. You can really go to town here. You can start off with the Lordy triangulation if you want to go into the 3D and supported the Voronoi spaces, and this could turn into something major if it works. Okay. The second technique that I also have not done yet, but I think it will work much better, because if you listen to preparers talk whatever, then he's already doing sort of this type of work. So at first we did time domain EM with the measuring B fields, and all the work that we did for Vedanta at Achenijs and so on, that was just the measuring the B field, and for the B field we just use a very fast sampling the magnetometer. But the drawback of the B field is that you cannot measure the start of the decay accurately. So if you want to look shallow, you would have to use the BDT, and there is our the BDT sensor at the bottom of the drone, our transmitter. Again, what we do is we lay out a big loop, and that little transmitter there coupled to a generator or to a big battery pack, whatever. I can give us 50 amps into a loop. I see these three photographs disappeared. I don't know why. Okay, that looks like my distillery up at home, you know. So the pipes coming down. Oh, he's in pipes. Okay. But there would be, you would get to a TSF, whatever, there it is. You would lay out a last loop. It doesn't have to be a square loop, because I can handle any type of loop. And then with a drone, you would fly across the flight lines, and here is an example of a B field data set. So that's inside of the loop, that's outside of the loop, and because we measure B field, we measure it in the presence of the Earth's ambient, the magnetic field, whatever. So the rough line is the magnetic field, and the little perturbations are the on and offs of the time domain EM signal. It's a 50% duty cycle, and we typically have 250 milliseconds off. It's on and 250 milliseconds off. The result, I hope, is going to look like this. Again, I haven't done this yet, and I would have a BDT type of the result. We use something different than what everybody else is using. We're using a S-layer approach to calculate and layered earth for each stacked sounding quantity, and what that would show is that you have some water accumulation in the central part of the TSF, and if you do this once in a month, whatever, then you subtract the one image from the next one, you would be able to see movement and all these kind of things. Just what is very important in these drone operations is the terrain. The following, we have to know exactly the terrain. This is Gamsberg. These are the true flight lines which were done down here on the right-hand side. You can see even going down into the crevices, whatever, of Gamsberg. These are true flight lines.
It's really tough to get.
Okay. I'm not limited to having a loop. I can also have a grounded loop, and I can have a grounded side pole. We will investigate all these options on not on TSFs, but on another I don't want to say problem on another scenario, we will see what works best for these very shallow scenarios. Thank you for listening.